I'm on page 127 in the packet. This week is all about factoring. We'll cover three methods today. Factoring out the greatest common factor is a review of what we did last time. I think some of these are even the same problem. 15x cubed breaks down to 3 times 5 times x times x times x, and 9x breaks into 3 times 3 times x. We can factor out 3x, and that will give us for b, every term of this has an n squared attached, and they're all divisible by 3. It looks like they're all divisible by 9 as well. We can factor out 9n squared. I'm pretty sure we did this one last time. We can pull out this 2v plus 1, and that gives us this. And this one works the same way. The greatest common factor is this binomial 3p plus 7. These last two are examples of how we can factor by grouping. Say we have we group two terms together like this. And notice what I did with the negative here. You need to be careful when grouping to preserve the negative and positive signs. If I look at the terms in this first parenthesis, the greatest common factor is going to be p squared. Over here, the greatest common factor of negative 18 and negative 42 is negative 6. And that leaves me and that's going to equal same as we had up here. This is an example of factoring by grouping. And if you're given a polynomial with 4 terms in this class, I think this is the only way you're going to be able to factor it. I'll do a couple of these as examples. X cubed minus 7x squared plus 3x minus 21. First, I break them into two groups. For this first one, the greatest common factor is x squared. And for the second one, it's 3. There's an x minus 7 attached to both. That becomes problem B. Again, split them in two. the greatest common factor between 8r cubed and 64r squared is going to be 8r squared. Over here, I just have r minus 8, but I can write this as plus 1 times r minus 8. And I have